We have seen that by using threading. How many approaches? 3 approaches with a different type of approaches with different examples we did, right? Now today we are going to enter into the deadlock situation I am going to explain, right? So let us start with the important concept called what? Synchronization. Second level explanation I am going to talk about it. Synchronization. So, and synchronization in threading, also called as what you know? Deadlocks. Deadlocks in threading. Deadlocks in threading. Okay. And so one more student today faced an interview with a company called SAP, Bangalore based company. The beginning question itself is called what? What is deadlock? He just met me in the afternoon. He almost taken 1 hour on Python. Around more than 60 to 70 questions he sets. More than 60. Almost 20 questions on data types. And all of a sudden they went to what? Deadlocks. So deadlocks means already we used to discuss in the class. What will be the deadlock occurrence? How do you overcome the deadlock? How do you come out of it? How do you get the locking? Locking with functional, locking with object oriented, all those things explanation it's done. And waiting for within 2 to 3 days, you'll be having, they said HR round. HR round will be there. Technical round qualified it seems. And HR round will be there. And we need to see after 2 days, HR round will be there it seems. After HR round, what questions you will ask and what you will speak. Next round depends on their interaction. Right. So let us go to the meaning of synchronization and deadlocks meaning. We need to get it into the class. So before going to enter into this, I just want to speak about a single example. Of course, that we are already discussed in the class. In the model, whatever the examples we have taken it, that is comes under model number 1. Model number 1 we can call. What is there in model number 1? What we are talking about next example is model number 2. We are entering into the model 2. Now we are entering here. This deadlock situation or synchronization is comes under model number 2. And what we have seen previous explanation is comes under model number 1. So what is this model number 1? I am going to give you. First term, I will give you model number 1. In model number 1, what is happening, students? I created a thread T1 is equal to threading dot. Already you are aware of it. Threading dot. Tell me. Thread of target is equal to function name. Arcs is equal to. T2 is equal to one more thread. Threading dot thread of what? Target is equal to one more function name. Like that we used to write it. What is this entire thing indicates? Thread T1. One function, right or not? Function 1. Thread T2. One more function called F2. T3 thread. One more function called F3. What is this indicates? What is this indicates? One thread, one function. One thread, one function. One thread, one function. Like that, n number of threads and n number of things are continuing like this. N number of threads are continuing like this. This is known as what? 1:1 ratio we can call. 1:1 ratio. That means one thread, one function. Executed concurrently. Got the results. Understanding this? One thread, one function. Because we have seen already, last class I think so. Last program, ovals program, squares program, even program, odd program. How many threads we created? 3 threads. With functional, with object oriented, without inheritance, with inheritance. How many threads? How many functions? 3 functions. Simultaneously was executed and got the final answer. Student last Spets. Are you online student? You are new, I hope so. Hold only. You know me. For this class only. Because I see, maybe because you are online, I hope. Okay, no problem. So this is called one thread, one function at a time. It is called 1:1 ratio. That is called what? Model 1. Today's concept is what? There is no question of getting any kind of, there is no interference of the threads. There is no interference of the threads. Next one, what I am looking today is, there is a function called FUN1. There is a function called FUN1 which is having some logic. There is a thread T1 is required, thread T2 is there, T3 is there. What is the target function for all of them? What is the target function for all of them? Function 1 only. These are all called what? Thread T1, thread T2, T3 created. All of them are entering into which function? Function 1. What is an output? Just don't tell immediately, think about it. How many threads are entered at the same resource? Resource means object here. Every function is called one object. How many threads are there? All of them are entering into which object? Same resource or same function or same kind of object. Yet a time they are entering. Can you predict the output of that? Can you predict the output of that function? Not answering. Simple, man. There is a traffic junction is there, junction. That means 4 places. All vehicles are coming at the same time. At the intersection point, what will happen? Some sort of unexpected result will come or not? The traffic junction, that is a intersection point of all 4 roads who are meeting at certain intersection point. If all of them are coming at a time, some kind of unavoidable situation will occur. That is known as what? Wrong result will come. Same thing. All threads came at a time to a single function. Can you predict the result? I am asking. You cannot. That is nothing but a deadlock result we can come. Definitely that result is not correct result. Am I correct? All of them are entering into the same function at a same time. They are doing some manipulation. That manipulation you cannot predict it. That result, whatever is coming, that is called wrong result. Such a type of wrong result is known as which result? Deadlock result. Such a type of deadlock result is called what? Non-thread safety result also we can call. Spell out. Because these are the different type of words. Non-thread safety result. Non-thread safety result we can call. Non-thread safety result we can call. Come in, ma. This is also known as what? Some people can also call it as a race condition we can call. Synchronization is actually a concept of operating system that we are implementing in Python on the name of what? Deadlocking. It is also a name, another name is called race condition. Come on, what are the different words? Spell out once. Race condition, deadlock situation, non-thread safety result. When do you get the deadlock result or non-thread safety result or race condition? When multiple threads are attempting to enter into the same object or same resource at the same time, we will get the result which is called wrong result, inconsistent result, thread safety, non-thread safety result. We can't get this output. There is no use of that output at all. We call it as which result? Also called as what? So what is the difference between model 1 and model 2? In model 1, what is there? One thread, one resource. Here, one resource, how many threads? Multiple threads are there. Multiple threads are using what? One resource only. You'll get which result? Deadlock result. In your college, they explain deadlock in different way. What is that? Process P1, process P2. They will write, everybody will write this result. Resource R1, resource R2. My sir also explained this only. So, resource R1 held with P2, P1. P1 is requesting for R2. R2 was already held with P2. P2 is waiting for the resource R1. And P1 and P2 are the called programs. R1 and R2 are called resources. To complete these processes, they need what? Two resources they need. One resource is held with one process and requesting for another resource, which was already held with what? Another process. This process is requesting for the another resource, which is held with another process. This is looking like what? Cyclic process. You are not releasing, I am not releasing. So both of them are waiting forever. That is called a deadlock result. You will get it in the college level. So both of them are waiting to each other. That is called one type of deadlock. Here operation is done. Here operation is done. But that operations are giving which result? Non-thread safety result. Spell out. Non-thread safety result. Students in the online, did you understand, guys? Did you understand what I am talking, mom? So coming to the point of it, when you go to the threads, I will show you some small symbol for you. Thread model 1 and thread model 2. Just one small example. Instead of drawing that, just observe it. Come on to the point back. T1 targeted to which function? FUN. T2 targeted to which one? FUN2. T3 targeted to what? FUN3. Each thread is running this function, giving the result. Each thread running the function, giving. Each thread running the result and giving. One thread is to what? So no question of getting deadlocks. Safety result it is. Understanding? Right. Separate lines for running separate places. Coming to next area. Model number 2. We are going. T1. Threading dot thread off. Target to what? T2 also target to what? T3 also same. T4 also same. That means T1, T2, T3, T4 are going to be called what? Subthreads. Subthreads. Target to what? Same resource or same method or same function. What is the result? Deadlock result. Non-thread safety result. Inconsistent result is going to come. Inconsistent result is going to come. What is the scenario finally? Multiple threads, one function. Multiple threads, one resource. Gives which result? Deadlock result. How do you avoid it? To avoid that type of thing, we are supposed to use one special class called what? A lock class we will use. What is the class name? Lock class. So let me go to that point. Let me go to that point now. Students in the online, did you understand this? One is to many and many is to one, that like this kind of things? Multiple threads, one resource. All of them are entering into the same function. We'll get the result like that. Let me go to the one example directly so that you can follow me better. I will take first one small example. A small example I will take it, where you can understand easily and you can seek very careful result. So I am taking DEF table. DEF table. I am taking N. I am taking if N less than or equal to 0. I am saying that to print invalid input. Invalid input. This logic you can understand because it's not a difficult for you. That's what I am taking first to this one. Else I will write it. Else I will write it. Print of what? Multiplication table for dot format of N. I will take it. Print of. I will take like this 50. Now I am saying another type of thing. Here I am going to take it. I will write it. Here I am saying print for I in range of 1 comma 11. I'll print this data. Print of \t something like this. I say equal to dot format of n comma I comma n into I. So this is the table function is created. This is which approach here? Which approach? Non-locking mechanism. Non-locking mechanism, functional, right or not? Non-locking functional example .py. Non-locking functional programming. Main program I am going to write it. How many threads I am going to create? 4 threads or 3 threads or whatever it is. Come on, T1 is equal to T1 is equal to, come on, threading dot dot thread of target is equal to table, comma, arcs is equal to some 4. Similarly, T2 is equal to second thread also same function only. I am going to take 14. Next I am going to take it T3. I am going to take it something like 9. Something like T4 I am taking. Something like T4. I will take it. I will take some the value called 19. Somewhere else I will take -9 also I will take. So here I will print the thread name also, student. Thread name. So I will say thread name also I will print it. So inside of it, let it be here. Thread name also I will print it here. Thread name. I'll just write it here. Thread name, comma. How do you print it? Threading dot. First one I will write it. Threading dot, thread name, and then multiplication table. I will write it there. Threading dot current underscore thread, comma, dot what? Name, comma, n I am passing. So execute this code. Yes, I'll import it. Let me save it. So there it is going to be 6 p.m. Under threads, I will save it. Non-locking functional example, I will say import threading. Let me use time also to see the fun kind of result. Time dot sleep of something like 0.5. 0.5, I say start the threads. T1 dot start, T2 dot start, and then T3 dot start, and all those things. T2 dot. So T3 dot and T4 dot start. So let us observe the result. That's all. Observe the result. Coming to the command prompt, E colon. Say go to that location. Say something like 6 p.m. Say threads. So threads execute. Py. See students. See that result. Once you just see the result, let it come as it is and see the result. Observe it. What is this result? Thread name 1, 4. Immediately 4 into 1 is coming. Some other thread is interfering there. And then thread 4, multiplication table for 19. 19th table is coming. Multiplication table for 14 and see the result. 14, 14 to 19 again came, 14 came, like that it is coming. Wherever you feel the result is going to be something like what? Not at all useful. And this is known as what? Because of all the threads came to which function? Table function. We got the result is come something like useless. No use of such result. Then how do you do this? I want parallelism, but I want a consistent result. Safety result I want. This is by using what? Non-locking mechanism. Which kind of result we got it? Deadlock result. Non-thread safety result came. Are you following? Now, how you can overcome this? Very simple. Immediately. This is by using non-locking functional example. Same code I will show you with object oriented also. Later I will provide the locking mechanism for all. Okay. Now see. I will say non-locking. What is this now? OOP example 1. And without inheritance, I mean. Go to that. You say what? Class MUL table. I say, coming to this place, TF table of N. N less than or equal to, else I got the result like this. Are you able to follow? Yes. Next I am going to enter into less than or equal to 0. I got something like this. Got it. Now coming to this place, execute the same thing. If you want, you can, I'm using directly self, I need to write it here. If at all you need this n as a self dot n, you can write it, no problem at all. That time I will write what? Self dot n, self dot n. Actually not necessary. If you feel pure object oriented like this, you can write it. Not an issue. I can write it. Self dot n and self dot n, you can write it. Are you able to follow? So coming to the point back, non-object oriented programming example 1.py. Go to this location and threads dot. I will do it. Yes, Bhavika, correct. So I'll come to that. Coming to the threads, I'll save this example. Non-locking, object oriented. There I need to take it as what? Create object. I will create an object. I'll create an object. How I am creating that object? See that T is equal to, what is that now? MEL table of. What is that now? T dot. T dot. Now I am saying T dot. Now I am saying T dot. T dot, T dot, T dot. And be careful. T dot, T dot, T dot means what? All of them are going to be careful. Answer need to say T dot, T dot, T dot, T dot. Finally, it is going to give 19th table or all of them. You need to observe it. Anyway, you observe it. Let us execute. Execute. See the result of that. Once again, non-py, non-object oriented example 1. See that 19th table only coming. Are you following this? So, 19 into 6, 6, 6, 19 into 8, 8, like that it is coming so many times. So, all of a sudden, 4 is not coming. It goes on taking only 19, only taking many times. What I do is, just observe it carefully. N into, self dot n into. What I do is, just I will give very good property here. So, let us go to the point back. Let us go to the point back. I say, MUL table of, already you know this process, right? See this. Here I will write MUL table of, written, done, execute. See students, now I am getting, see this, carefully observe it. What is the answer is coming? Same as previous or not? You will not understand that result. That is called deadlock result, non-safety result. If no traffic police, all people are coming in the same intersection. What will happen? This is nothing but what? No control over my threads. All of them are coming to which function? Which function they are coming? Table function. No such proper result is coming. I want to control this flow. Shall we start? This is by using without inheritance or with inheritance. This is without inheritance. Okay, sir. Last and final, sir, you tell me with inheritance, sir. Now I am going to enter into where? With inheritance. With inheritance you go, sir. Now I am going to say, sir, with the inheritance. Non-locking only with inheritance, sir. Say what, sir? Here I will say, come on. Threading dot. Thread of which function? Run function of just self. Okay, this I should not. What I do is, I should not write like this. You know, this we cannot write it. What I do? Tell me. I will say MUL table of. MUL table of. I say MUL table of. MUL table of. Next I will write MUL table of. Sorry. MUL table of. Again MUL table of. MUL table of. I say. So MUL table of. So I got it, I hope. So here T1 is equal to MUL table of. T2 is equal to MUL table of. T3 is equal to MUL table of. T4 is equal to MUL table of. Are you able to follow? Yes. Coming to point back. Now I'm going to say we need to set the value or not. Self.n also required. How do you say the value here? I will say T1 dot what? Set value. Compulsory you need to set the value. What is the value of previous one? 4 to 14. I'll say 4. Next is called what? T2. T2 dot what? Set value 14. Next is called T3 dot. T3 dot set value minus 9. Next T4 dot set value. What is this? 19. 19. Now set value function I need to define. DEF. Come on. Set value. Set val of what? Self. Self. Comma what? N. Self dot n is equal to n. Self dot n is equal to n. Self dot n is equal to n. Are you able to follow? Yes. Now come on and execute this process. Non-locking object oriented example 2.py. Py. Execute non-locking object oriented example 2.py. You say py non-locking object oriented. See the result here. What is the result is coming? Same result or different result? Same or different? Same. That is known as which result? Deadlock result. So in 3 different approaches we checked it. Functional, object oriented without inheritance, object oriented without inheritance, object oriented with inheritance. I hope you are understanding this entire mechanism. Did you understand? Yes. Now I will solve it, sort it out. Now I will go to first functional part. I will take it. Copy this. I am going to provide what? What I am going to give you now? Locking. Consistency. Correct result I am going to generate now. Start. Here, lock functional example 1.py. Locking I am providing. Which kind of class I need to take? A lock class. Okay. Now, locking means what? All these threads are trying to enter into which function? Right. Now, which one will start first? T1 will enter into which one? Table function. Assume that table function is something like a room. Like a room. Who is entering inside? T1 is entered. T2 is also trying to enter. T3 also, T4 also trying to enter. Locking concept says when T1 is entered inside, you please lock your room. Locking the room is nothing but make other threads to wait until T1 complete the execution. T1 completes the execution. How do you do that? By using the concept called what? Lock. Once T1 completed, permit T2 again lock this function. When T2 completed, permit T3. Complete T3. Again permit like that. Locking, unlocking. Locking, unlocking will be continued until all my threads are completed their execution. Did you understand this? Go to the mechanism. Go to the mechanism. Now I am going to say T1 dot start, T2 dot start, T3 dot start, 4 dot start. Now I am going to give you the clarity here. How do you implement? First step is create an object of what? Create an object of which class? Lock class. How do you create? L is equal to what? Lock of. What is L? Object of? Okay, good. Written. Here an object here. L is an object of. Is an object of what? Lock class. Lock class. And it is a global variable. Global variable. Right or not? Room. Now who is starting? T1. For T1, T2, T3, L can be accessible or not? Good. Go to that. Where are you going? Table. How many functions? How many threads you have started? 4. 4 threads started. That means 4 threads are entering inside what? Table. Which statements must be locked by one thread at a time? Those highlighted statements must be locked. Once T1 entered inside of it, you must immediately do what? L dot acquire. L dot what? Acquire. Acquire means what? What are all the statements are previously executed parallelly, which you have seen deadlock result? Those statements must be executed by one thread only. Before all the statements, I am just keeping the bolt from the backside of my room. That means these statements are fully protected from other thread when some thread is executing. Are you getting my point? These statements are supposed to execute how many threads at a time? Only one thread. What I am writing here? Acquire. And after completion of it, what I am doing? I am releasing the bolt of my room. This is nothing but what? Release. Release. How many functions are there? Get the lock. Get the lock. Get the lock. And next is what? Release the lock. When I am releasing the lock, after completion I am releasing, before entering I am acquiring. Suppose, for example, T1 is inside and T1 already got acquired, and who is coming inside? T2. PVM will not permit the T2 inside because the statements are already locked. That is not permitted until who will complete? T1. Once T1 releases the lock, then only the next thread which is in the queue will be permitted. Are you following? T2 will acquire the lock, execute the statement, release the lock. Acquiring, releasing, acquiring, releasing. This process will be continued until all my threads completion is completed. Are you following? Let's execute. Now I am going to execute my operation. Let's start this discussion. So, coming to this place, now I am going to say, save this code, execute. Now come on, PY, see the students. What is happening? Lock is not defined. Okay. I should write what? Threading dot lock. Threading dot lock. Good. Now you define. Thread. First 4 is coming. When 4 is executing, what is happening? Thread 2 is coming now. Thread 3 will come later. Thread 3 will come later. Next called what? Thread T4 will come. Thread 3 T4. And 9 is invalid. 9 is invalid means what? T3 related kind of thing. Are you following me? So, what is this result is wrong result or safety result? Safety result. How many steps are there? 3. Number 1 is called what? Create an object of what? Lock class. Whichever statements are parallelly executed by multiple threads, before that you acquire the lock, and after completion of that statement, you release the lock. When I am coming to my class, I will lock my class. Why I will lock the class? No other class people should come to the class. Because one operation is going on. If other operation is going on, it's going to be output is wrong. That's why I will acquire the lock. And when my class is over, I will release the lock. Let them other person to come into the class. Are you following? So, coming to the point of it. Now, you may ask a question, sir, we can use a sleep method also here. After T1 is over, sleep. After T2 is over, sleep. After T3 over, sleep. After T4 over, sleep also you can say. Correct or not? But what is happening after that? I don't know how much time T1 will execute. Na? It may execute 10 seconds or 15 seconds or 20 seconds. I don't know. That's why I will say what? Let it acquire. After finishing it, it voluntarily releases the lock. Releases the lock. Are you following? If I don't release the lock, no other thread will come. You want to see that? You see once. I will just say, I'll keep comment for this. Which one? 15th line comment. Who is running? T1 entered. What is happening? Acquire. What is the result I got it? What is the result I got it? Fourth coming. What is next? T1 is not releasing the lock. It is holding only. Who is not coming? T2. Output will not come at all. Just to see. Execute it once and see the result. What is happening? Fourth is coming. It will not come. Nothing is going to come. Just wait. Nothing is coming. Waiting. Why? It is not releasing. What is happening? I hold that the bolt is kept in the backside and people are knocking the door. You are not opening that. What to do? Break the door. So, coming to that, it is, if you come tomorrow also still holding the lock. So I'll say Control C also not breaking. Control C means cancel the execution. It is not giving the locking also. I need to close my command. Close the command. Close the window. Closing of the window only. Again I have to go for it. So program releasing is compulsory. Did you understand this explanation? Go to the place. I say here, I'll go to once again that entire story. This is an important part to remember. Lock, once you acquire, you need to release the lock. Python 6 p.m. under that threads under enter. Otherwise, no timing is going to work. Locking is locking mechanism. I hope you are understanding this. Students in online, how many steps, guys? 3 steps. 3 steps. This is called what? Non-functional programming locking and functional programming locking. I got it. Shall I move forward? Good. Next I am going for non-locking functional example. Shall I move forward? This example I will take it. This example I will take it. Go to the place. Come on. Now I will take it. Right, students? Come on. What is this now? Lock object-oriented example 1 without inheritance. Come on. Same. Can I take the same? Tell me what to do. INH something like oops only. Oops example only. Example 1 I will say. No problem. Say here I will create what object? Come on, simple. I will create an object of what? Lock. Okay, sir. Creating. Nice. What are you doing next? Tell me. Don't create inside the lock. Don't create inside the lock. Creating the lock and then locking inside. When you came inside the room, no lock creation is there. We cannot. Lock should be global for all of them. Or one lock only you need to create. So create inside, that is done. What should you do? Come on. L dot. That's all. And don't come and ask me, sorry, necessary to write capital L. Just I am writing for easy recognition. I will write here K. I am getting key on that. Key on that. Here K is called what? Some object. Global variable. K dot lock acquire. Next is what? That's all. That's all. So K dot release. K dot release. K dot release. Release the lock. I hope you are understanding. So take the indentation properly. Take the indentation properly, right or not? Yes. Why? Either negative value, release the lock, or positive value, release the lock. Okay. Save this code. I will do multiple ways. Done. Start that output now. PY. See this now. Getting the same answer. Getting the same answer. This is something like what? So output thread 1, thread 2, thread 3, etc. will come. No issue at all. Here, output is coming. This is purely like this. Next, I'll go to one more way. I say Python here. Now see students, I don't want to go like this. I want to go something different way. Can anybody can say in another way, how do you do it, ma? I will take it. Lock is only one time. Lock is only one time object. Common for all of them. What method I have to define? Come on. Every day you will come to the class for attendance. So, at the rate class method, yeah, Bhavika said, at the rate class method, I will say def get lock. Get lock of what? CLS. CLS dot. CLS dot. CLS dot. K dot. Threading dot lock. What a beautiful subject. Long ago, there was instance method, class level method, static method. So whoops. Whoops is whoopsa. Whoops is whoopsa. Whoops is whoops, but not coming. Energy is not there. Not reading. CLS dot K, threading dot lock. Okay, sir. Now I need to acquire or not? How do you acquire? K is what type of variable? K is an object of lock class. Acts as which variable? Of course, based on my writing only will change your party. Global variable, class variable. If I write something, no, sir, this variable, sir. How do I access class level variable? With respect to class name. What is the class name? MUL table. How do I access this K? MUL table dot K dot acquire. Long ago, class level variable must be accessed with respect to class name, must be accessed with respect to CLS, must be accessed with respect to self, must be accessed with respect to object name. 4 ways. But what is the possible way? I can access class name. I cannot access CLS. I can access self. I can use. Oops is oops. It is not possible to learn everybody. Only few people can remember. Right? Like you and me. Like you and me, not others. Okay, something happened there. So, save this example, save this. Out of that, PY, see here, without inheritance, MUL table, okay. So, T1 dot, no problem, T1 dot start, okay. This MUL table, do what? Get, call the function name first of all. What is the function name? MUL table dot MUL table dot what? Get lock off. Okay. PY. Antena? Right. Answer is that. I need to invoke the lock. Without lock, trying to keep the bolt, nothing is going to be. K is not defined, something is saying. What is K is not defining? It is giving an error. Release. It is saying. I need to write class name or not? Class name, I need to write it. Class name. What is the class name? MUL table. So, that is becoming, here you locked it, but you are not using MUL table. That's why it is permanently locked, permanently blocked. Doors breaking, not coming. So, you locked it, but variable you are not using properly. K is not defined. Here it is not at all going to be possible. This one is. So, you locked properly only, but unlocking time you are using wrong variable name. So, I should write it. And don't ask me, sir, you are writing now, it should come. It will not come now because it is already program started. Even if you say that it will not come, I need to type it. I need to save it properly. MUL table.k.release. Now you go. E colon, say KVR, Python, something like 6 p.m. Say something like threads. I say PVM, PY. See this coding level here. What is this now? Execute. Now see students, now output is going to come like this. So I hope you are understanding me, getting this result like this. Fine. Finished or not? So what is the concept used? Decorator. What is the decorator name? @ class method. How I am calling? Mutable. Multiple. So MUL table. Can I use self here? Yes, sir. thinking like a scientist. Yes, I can use. I told that class level variable can be accessed in 4 different ways. Self I can use because self is there na. Every class level variable is a common. I can access self. Let me write last and final. Self. Here I will write what? A self. Self. Okay, one place self, one place that one. No problem. One place self, one place, no problem. No problem. Start. Go to this. Run this. Okay. Sir, same numbers. No, sir. 14. Say something like 8. Something like 16. And something like something 23. 23. Run this code. Getting that. 14. 8. 9. 16 is invalid input. 23. Finished. So, simple. Are you following? Right. So here one place self, one place MUL table. When you open the notes, don't get confused because already it was discussed. Right. Next I'll go for what? Sir, next what, sir? You only tell me, sir. Non-locking with inheritance. Non-locking with inheritance. Huh? What is that? Sir, Litun. Sir, can we also write inside of CONS? CONS. 100% you can write Litun. You can take constructor. But constructor, I don't recommend because constructor will call each and every time. Each and every time, don't go for it. But see, when you are writing the code, always look for optimization. Class level means how many times? Only one time. Beginning time only you are calling. Beginning time only you are calling. See, my dear student, beginning time only you are calling. One time only you are calling, which is most useful for everybody. But when you write constructor, what will happen? Every time lock is creating. One time locking is enough now. Why should I take more number of times same lock object to create? Waste of time now. Litun, did you understand that performance point? Did you understand that performance point? Manaya, correct, exactly correct. Space complexity and time complexity is more. That's why we would like to go for class level method perfectly like this. Well, next I'm going for this one. With inheritance, I want to go for it. With inheritance, I want to go for it. Final stage. Final stage. Now I'll go for what? Same thing. Go to this. Others here. I will take it. Come on. Here I will write it. Same thing, students. I'll go for it. In this place, I do like this. Which variable? Come on. Challa Satish. The purpose of threading is simultaneous execution. But here it is. Executing. It's writing spelling mistake. Executing one by one thread. Totally is writing wrong. Totally executing this is. C. ATM operation you take it. Challa Satish. Try to think. I hope you are supposed to understand. I'll go to next example also. This is the machine you are running from where? You are seeing that this is running in where? In the same machine. Suppose this program is available with me in my server and you are sitting in different machines. Those machines are connected to my system. Tell me how you will get the result. You will get your own result. Somebody will get their own result. Somebody will get their own result. The other person will not see your result and you will not see other person result. And how they feel? How they feel? Will they feel that they are getting the result simultaneously or mixing and coming or one by one coming? Here you are feeling the result is called what? After one person result, another person result is coming. So Challa Chadish is feeling that it is coming sequentially. He is feeling like that. But if you think so perfectly, you are sitting in three machines and those 3 machines are connected to my system. What is my program name? What is my program name here? MUL table. I gave it in the form of a package and you are downloading that and you are writing sys.path.append and you are importing my module, creating your object. Somebody also created their object. Somebody also created their object. They are sending the request to me. How my program will give you the result? First program number of multiplication table to that machine. Next person also getting the result of that corresponding number. Next person also will get the corresponding number only. The first person will see the first person result only. Second person will see the second person result only. Third person will see the third person result only. Not seeing the other person result like I am showing in the same machine. Here I am showing in one machine 3 people's results I am showing. But in reality, how it is? In one machine, I have a threading program and other people are doing what? They are checking parallelly or one by one? Parallelly. Simple example, if you did not get me, take Gmail. Gmail is one or many? One. You are checking your own email ID, I am checking my own email ID, somebody checking their email ID. While you are checking your email ID, will you get my inbox in your machine? No. But when I see all of them here only, I will see all of them people's email IDs or not. So here you should think, I am executing total threads in my place only. But in reality, what is happening? Different machines, different requests will come. Those requests are going to get different type of outputs will come in different places. Are you getting my point? So that is the point you have to understand, Satish. I hope Satish understand my discussion. Are you following? So this is not a sequential execution. This is what execution? Parallel execution only you have to understand. Right? Understand. Now go to the next part. Next part. With what? With inheritance I am going to show you. How do you do this now? I am writing there. I am going to this place. Just like this I am writing. K is equal to, I am not writing that class level method and all. Just I am writing like this. Which variable? Any variable defined inside the class is called which variable? Class level variable. And you are thinking like a whoops is not completed like. So here K is called which variable? Class level variable. Here K is called class level variable. Here K is an object of law class and it is acting as what? Class level variable. Set value self dot n is equal to n, run, invalid input and printing like this. Same to same. Here in run place, what should I do? Come on. Acquire. How do I acquire? How many ways? Huh? How many ways? How many ways? 2 ways. What is the first way? Huh? Tell me, don't try to memorize by what do you call? Making noise in your mouth only. Say answer. Up. Kartikeya, right imposition. Right imposition. Come on. Self dot K dot acquire. Acquire. Can I use CLS Kartikeya? Kartikeya, first time I hope you are answering wrong. So, CLS. Can I write CLS? Why? Because CLS is a formal parameter, nowhere else existing here. And that too you are in the context of instance, where is the CLS parameter is? So CLS we cannot use it. I can use class name. I can use a class name I can use. Why class name is going to be available for everybody? MUL table dot K dot acquire. You can also write it as what? Self dot K dot acquire. And last I will write it what? Kartikeya, did you understand? MUL table dot K dot what? Release. Release. Kartikeya, did you understand? Okay, good. Now you see acquiring the lock and then releasing the lock. Where I am writing in? Where I am writing, boss? Run. Where I acquired it? As a class variable. No, sir, it is bouncing. When you practice very perfectly in whoops, it will not bounce. Because whoops is always whoops. If you make it that policy, definitely wherever whoops will come, will become dull. Right, done. Whenever I get whoops now, I feel a lot of relax. Relax. Because difficult things always makes very easy. when you practice it. Let us start running this. Same thing. Class level variable created, acquiring the lock, releasing the lock. Run this code. So I'm saying lock, oops, example. What is this? Inheritance, example 1. Dot py. Dot inheritance, example. Dot py. Save this. Save this. Why I am not taking instance variable? Instance variable, why I am not taking? Because it is not a particular object. It is a global for all the objects now. What are the global variables in the oops? Class level variables. Functional programming, global variables. Object oriented programming, class level variables. Object level variables are what? Self related. Simple. Py. So getting the result, same type of result which I have previously, that result only will come, because in my program I told this value is 4, 14, like that only it is coming, like that results are coming. Are able to follow? So this is known as what? Locking with what? Object oriented programming. How many steps are implementing locks? 3. Number 1, create an object of lock class. Number 2, prevent the deadlock. So acquire the lock. Where do you write? Before the statements which are facing the problem of parallelism, write acquire. Next is what? At the end of the completion, write what? Release. Shall I show you the content now? So what is the synchronization says? When do you apply? First of all, what is the need of synchronization? Synchronizing means making the threads to mutual understanding and giving the result as accurate, safety result. When multiple threads enter into the same resource, resource means what here? Object called a function. By default, we get which result? Deadlock result. Deadlock result will come. Or non-thread safety result will come. Inconsistent result will come. We call it a race condition. To avoid this kind of thing, we will go for what? Locking. So to implement this synchronization and to implement this deadlock elimination, we'll go for lock class. Create an object of lock class. Acquire the lock. Release the lock. Releasing, acquiring, acquiring, releasing will be continued until all my threads completion is completed. So I'll show you a small example, small explanation I will show you first. There I will take it threads where I shown you that example, that concept is there. I'll show you first. Please read out this documentation first. When multiple threads are operating or working on what? Same resource, maybe a function, or if we go for functional programming, function. When you go to oops, it is called a method. Then by default we get which result? Or what? Or what? Wrong result. Also called non-thread safety result. To overcome these deadlock problems, we must apply the concept of synchronization. We must apply the concept of synchronization. Or we must apply concept of synchronization. Next, the advantage of synchronization concept is that to avoid deadlock result and provides thread safety result. Provide what result? Thread safety result. In Python programming, we can obtain synchronization concept by going for locking and unlocking. So how do you implement? Steps for implementing synchronization concept, or steps for avoiding deadlock result. I can write steps for avoiding. I will write here steps for avoiding deadlock result. Steps for implementing deadlock. Implementing steps for avoiding deadlock. Avoiding which result? Deadlock. Deadlock. First step, obtain or create an object of lock class, which is present in which module? Thread module. Lock object is equal to threading.lock. Threading.lock. Second, to obtain the lock on the shareable resource, we must use acquire. Syntax I am writing. lock object dot acquire. Next, once current object acquire the lock, other threads are made wait until current thread object releases the lock. Other people made wait until current thread releases the lock. Next, to unlock the shareable resource or current object, we must use so lock object dot release. What is this? Once current object releases the lock, other objects are permitted to enter into the shareable resource. This process will be continued. Process of acquiring and releasing the lock will be continued until all the objects completed their execution. This process will be repeated until all the threads completed their execution. I hope this is comes under what? Avoiding what? Deadlocks. I hope you are understanding about three different approaches. One is functional. This is called non-functional. And next is called non-locking whoops. Non-locking whoops with inheritance. And locking functional, locking option object oriented without inheritance, locking what is this? Object oriented without inheritance by class level method, and one more is called what? With a class level variable. Different ways in whoops. Are you okay? So now I will go for one more example. Students in online, did you see the Vijay Mallya? He is there in where? London. He is in London, enjoying there. Now, so to Kartikeya, you need to give 5 lakhs. To Kartikeya, you need to give 5 lakhs. To next is called, to Naveen, you need to give 6 lakhs. So next is called to Manaya, you need to give 10 lakhs. And next like that, different to our students, you need to give different money. So like X student is having some money. Second, like Kiran Kambli is there. Next is called some different students are there. So he needs 7 lakhs. He need 8 lakhs need to be given. But he is having only 10 lakhs in his account. One day he came to Hyderabad. All these people came and met him. And immediately, how much is the total amount? 5, 6, 10, 21, 28, and then what? So, this is how much? 8, okay. 36 lakhs is there. So Vijay Mallya is a so intelligent guy. That's why he came out of India and went out. So when our constitution is very good, he will come back, because our constitution is not good. So coming to the point of it, 10 lakhs. He is having only 10 lakhs. So Kartikeya, he is saying, come one by one, don't come all of you. He given a check for Kartikeya at 5 lakhs. Kartikeya is very happy. He got my 5 lakhs. This Naveen also got 6 lakhs, and whoever is coming, he is giving that money only back. Everybody giving. And next day, today is a Sunday. Okay, tomorrow all of them are going to the bank only. Put that checks in their banks. What will happen? All the things go to Vijay Mallya account in Amirpet, ICICI Bank. It is coming. What is happening? This person check is passing, and other people are bouncing. Right or not? So what is happening? That is, internally ICICI banking server is containing what? Multiple people are going to come to the same account at the same time. That time what is written? The rule, deadlock rule is written. Suppose they did not write any acquiring and releasing, what will happen? Everybody check is passing. Who is the final loser? Banker is a loser. Am I correct or not? That's why they wrote what? Locking mechanism they kept. Why? For one account, multiple people may be giving the checks. That time when it is coming, bounce. Come to next, one more example. Don't tell this example there. This is a train. My train is containing 4 seats, 5 seats, 6 seats, and then 5 seats are there. This is the train. IRTC, some project is there or not? red bus, Abhi bus, something like this. Totally how many seats are there in my train? So different people want to book their ticket. What is that? Same number, train number 14156, something like this. And the Rosam want to book 4 tickets, and the Gosling want to book 10 tickets, and this person, something like Travis, want to book 15 tickets, and other person want to book, sir, 6, other person 2, and then 4. Now, Rosam is the first person entered into the same train and 4 tickets. Yes, booked. Next, Gosling want 10 tickets. Also booked. Also booked. 15 tickets not booked. Why 15 tickets not there? 6 tickets booked. 2, 4 no seats available. No seats available. All the threads are going to the same train. Will give what? If I don't follow the deadlock mechanism there, when your request is crossing, if other request is coming to the same seat number, same compartment, and etc., will I give the 2 tickets at a time to the same train, same seat? If I give same seat number and the same train and same timing, when both the passengers will go there, what will happen? Nothing. And why fighting? What is there? Why to fight? Earlier, olden days, that is the fighting. Nowadays, nothing will happen. Both of them will go. These days, passengers are very smart. Going to the train people, asking that fellow, what is this software you are maintaining? Put a case against them. With the penalty, they will get the money back. So, software problem. Software problem means playing with the people's comfortability. So that is a big crime. That's why software implementation, if any person developed a train software without knowledge of multi-threading, okay, train people are paying and they will see who developed this, which company developed it. In that company, who is a software employee? That software employee will be brought. And finally, return the salary. So who is the final victim? Developer is the god here. So we need to go for carefully. Shall we go for this development? Which development I will go? Right. Now I'll go for train reservation. Shall we do it? Start. Train reservation. Quickly. Class. With WUPSA, without WUPSA, with functional, what you want? With WUPS. Okay. Class. What is this? Train. DEF. DEF. With inheritance or without inheritance? With inheritance. Okay. Train of what? Train of what? Threading dot. Thread. Threading dot thread. Okay, sir. Import. Threading. Import what? Threading. Next. DEF. DEF. Come on. Next. Reservation. Reservation of. Reservation of. Okay. You are going for what? Run method. I will take it. Right or not? Run method. Run method of what? Self. Okay, sir. Self I will take it, sir. Okay, sir. For 2 minutes, sir. DEF, sir. DEF. Set seats. In my seats. Self dot. Self, comma. Seats. Seats. Self dot what? Seats is equal to what? Seats. Okay, sir. Coming to pass, sir. Okay, sir. Keep it 1 minute. Wait, sir. Main program you come, sir. Main program you come, sir. Say. Come on, sir. T is equal to train off. T is equal to train off. T is equal to train off. Okay, sir. Train object is created. Train object is created. T dot what, sir? Seats. How many I am having, sir? 20. 20 seats are created, sir. Do what now here? One lock object also will create or not? What is it? What is this? Something like L is equal to what? Lock. Off. Threading dot. Lock. Already you know, I need not read the description. This is called which level variable? Here, L is called which level variable? Class level variable. Class level variable, class level variable. Okay, come on, pass. Come on to the point back. Now, I'm going to say, with this now, T is created. T1 is created. This is called what? Train. Object is created. Now I need to go for what? Number of seats reserved. Number of seats reserved. Now I need to go to what? Reservation concept. I need to take it or not? So coming to this point, here I'm going to take it. I will take it. In this case, seats I'm going to take after reserving this ticket, coming to this place. Here I will write the logic. How earlier we are passing that? You see with inheritance what is happening? T1 dot MUL table. One object is created, second object, third object, number of things are created. Right or not? So here what is happening? Train is created, seats are available, train is created, number of seats are created, one object is created. 1 minute ma. How many threads here created? Previously, one multiplication table contains run function. Run function. Here how many threads are entering? 4 threads are entering. 4 objects are created. Now, here in the run method, 20 seats are available here. That 20 seats also I will take it as a, instead of saying there, seats I will take it is equal to 20. Seats is equal to 20. What I am doing now? T1 is equal to train. T2 is equal to train. T2 is equal to train. Next is going to be T3 is equal to train. And next is called T4 is equal to train. How many objects I am creating? Same train objects. Same. Whatever the train name it is, whatever it is. In that train, what are we doing? T1 dot, what we are doing to do? Reserve. T1 dot what? Reserve I am saying. RE, reserve. I am taking one more thing. Reserve. How many seats this T1 want? Some 10 seats. T2 dot reserve. I will write the reserve function also. I am saying something like 15 I am writing. Something like 15. Next I am writing T3. I am writing T3 dot. Next T4 dot reserve. T1 dot, T2 dot, T2. Here it is taking how many? 4. For example, here it is taking something like 2. Okay, like that. Let it be up to here. Now I will write which one? I will take what? DEF. What is the function name? Reserve. Spelling mistake, take care. Reserve. Of what? Self comma number of seats required. Required seats, RS, I am taking. Okay. Now I am writing self dot RS is equal to what? RS. Understand? Fine. You say from there, what I am doing, RS dot self dot start I am saying. Self dot what I am saying? Start I am saying. Okay, after a few minutes I will say. Not a problem. Okay, let it be. Instead of making you confused, I'll come to this. How many? 4 objects are created. Reserve. All of them are going to the same reserve function only. Next I will go for what? T1 dot start. Next is what? T2 dot start. Next T3 dot start. T4 dot start. How many threads are starting? 4 threads are calling what? Run. When you go for T1 dot start, in this place, I'll just take little up so that you can understand the flow. When you take T1 dot start, what will be the data coming? T1 related RS will come or not? What is the T1 related RS? 10. That 10 must be compared with the seats or not? How do you write the code here? Both of them are called what? This is called a class level variable. Here, I will write it here. What is this? Coming to this place. Here, what is this? Seats are called which variable? Tell me. If, come on. Seats are. Come on, how do you write it? Train dot train. Back to this place. Train dot, actually, oops with inheritance is little important. Train dot, seats, train dot, seats, seats less than self dot rs, say print of, I will write hi, that name of the person. You don't have that many seats in my train. Fine. TRAIN. Okay. Dot format of, come on, thread name I need to print. Thread name is another passenger name. And that RS I need to print. Seats are 20 ma. You are expecting more seats. That thread name. How do you get it? Threading dot current thread, current underscore thread dot name, comma, self dot RS. Mind blank. Not understanding anything, sir. Self dot RS is called what? My reserved number of seats already there. Come on. Who is coming? 20 is, for example, who is coming? T1 dot reserve. Okay. Reserved seats. Now you said T1 dot start. When you say T1 dot start, who is coming? T1 related self will come. Train dot seats, how many? 20. Self dot RS, 21. True na false? My dear student, 20 less than 21. Maybe rain effect, I hope so. 20 less than 21. Then false you are saying. So, hi thread 1, you don't have 21 seats in my train. 21 seats are coming like this and printed. Okay. Good, sir. Next, if we have, this is called what? How many I am expecting? 10 only. Train, how many seats? 20. 20 less than 10. Say, I don't mind anything. Say. False. Okay. False means coming to where? L spot. What should I do? What is your knowledge, students? Train dot seats is equal to train dot seats minus self dot RS. How many seats you have? 20. 20 minus 10. Right. So, I say, I will write it here. I say, hi, you have reserved. I am writing. You have reserved the seats in my train. Happy journey. Now I am writing. Next what? I will say. Next, are you following? Next, after coming out of it, now I am saying print of what? Available seats. Available, still available seats I will write. Still available seats. Available seats is equal to dot format of train dot seats. Okay, now I got it. What is happening? Where I am writing? Here it is totally out of order you are giving. How many seats are available you are saying? So if you have 20 passengers but only 10 are there, not possible for you. But for the less than that, it is possible. Still I am showing a vacancy. Are you following? When you say start, will you all of them permit at a time? Will you all of them permit at a time? But you are going to acquire the locking and unlocking or not? Come on, lock it. Lock it. Train dot L dot acquire. Acquire. Online students, are you with me? Are you following with me? Yes. So coming to the point of it, acquire. Students in online, are you following me? Yes. Last I will do what? Here I will say, in the else part I will do, guys. Here I am writing dot release. Release I am saying. Release I am going to say. Are you following? Train dot L dot release I am saying. Understandable? Execute. Eligible to? What is this line number 3? Suvendu. So, online is good, offline is good. Offline good, online good. Offline good, So you attended online or not? These 2 days which I did not feel well. You online attended or not attended, ma? So, anything is good once you concentrate. True, false to 20 less than 20. I asked 2 minutes, I was waiting. False. Like that. Okay. Why L is a local variable? Where L is a local variable? Rajarao? Why L is local variable? L is a local variable? Class level variable. Who said it is a local variable, my dear student? So, coming to that. Execute. Come on. PY. Say all of a sudden. Hi thread 1. You have reserved 10 seats in my train. Still available seats are 10. Hi thread 2. You don't have 15 seats in my train. Still available seats are. Hi thread 3. You have reserved 4 seats in my train. Still available seats are 6. Hi thread 4. You have reserved 2 seats. Still available seats are 4. Right? So, like this you can go for it. Like this you can go for it. What is the T1 dot hi thread 1, thread 2 it is saying? Can I give the name of the thread? How do you give the name of the thread? Definitely you cannot answer. Very good. Litun is perfect. T1 dot name is equal to Litun. T2 is equal to T2 dot name. T2 dot name. I told deprecated attribute. Get name. Yes sir. After saying yes sir. So next is called something like, I will write T3 is equal to, I will write so T3 dot name, okay. T3 dot name, T4 dot name is equal to, who is that? Suvendu name I don't write because he is asking wrong doubt. That's what I am not giving that name. Something like Raja Rao answer I will give. Right. Like this I am giving. Now you see students, last also one more T5 also I will create. T5 is equal to train of like this. T5 dot name is equal to KVR. Now I will write T5 dot reserve. How many? 6 seats. So T5 dot what now? Start. T5 dot start. Now I will say in this case of giving, I will say some small timing also to see all of a sudden not correct. Slowly I will show you the result. Execute. Import time. So you will remember import things for very nicely. Okay. Done. So Litton, you reserve 10 seats, 15 seats, right? Fine. Right. Gone. Finished. Are you following? So this code is most useful to you. You can implement for check withdraw facility also, deposit facility also. Are you following? If you try to implement in multiple machines in networking, if you keep it, threading application will work like anything. Deadlocks is important. Easy or difficult? Easy or difficult? But 20 less than 21 is very difficult. 20 less than 21 is very, very difficult. That is so very big doubt. That is. Okay, students. Anyhow, you need to practice. Okay, now students, shall we stop the class? This is about threading. Okay, now you practice this example. Tomorrow, I am going to introduce decorator, iterator, generator. Easy, but please practice tomorrow. Minus 20 greater than minus 19, minus 14. Tomorrow I will ask to every student, I will ask these questions. Because when you said that answer, I am only unable to believe, Tomorrow I will ask to every student this true or false for 10 minutes. Okay, na? Sir, tomorrow if you attend online, what you will do, sir? If you fear my questions and if you go to online, I can't do anything. How many times you will escape? Tomorrow interview will escape, huh? So face it. Right or not? Yes. So anyhow, we will go for it. So these days, okay, anyhow, we will go for it. We need to write a very big code, very good code we need to write it. So practice well and try to do that. So tomorrow class, I'll go for this is threading concept implemented. I'll go for tomorrow, decorator, iterator, generator, easy topics there. After that, networking, I will go for it. Okay, na? Right. Thank you, students. Good day. Good night.